Hi, everyone, and the live stream world beyond. I have the task of synthesizing our whole morning in 15 minutes and summarizing, and then thinking about action items for us, and then turning it over to the afternoon, which is the case study by Professor Kareem Lakhani, which will be a really, I don't know if y'all have looked at it yet, but a really interesting case study about medical imaging and deploying artificial intelligence in that space. So I will do my best to summarize and synthesize the amazing talks we heard this morning and think about some key takeaways that we had, which the last panel also covered as well. A little bit of why I think Megan asked me to do this. I am at my core a computer scientist. I found myself into healthcare via places like Google Health, where I worked on patient health records. I also worked in a bioinformatics lab and got an introduction to microarray analysis. Spent a lot of time working with EHRs and dealing with data on the back end for electronic health record system. Learned that a lot of companies that develop EHR systems don't have design teams that go and talk to doctors, and thought that was nuts. And really learned a lot about how different kinds of healthcare technologies are developed, but mostly from the engineering and product perspective. And then I also spent a few years working at an organization called the United States Digital Service, which is a tech startup inside the White House under President Obama, thinking of ways to bring digital into government in the same way that we think of how to bring digital into healthcare. And someone had pointed out earlier that maybe one day it'll just be called healthcare and not digital, because it's such a deep foundation of what we do. And I would love to also see that happen in the space of healthcare as well. And then also spent a few years with an organization called Unite for Sight on the ground in India and Vietnam, looking at just doing mass cataract surgeries for populations in that region, and just seeing what that kind of a mission really takes. So to think about this morning, before Anne talked, Bernardo and Ashish kicked us off really by thinking about really big picture, the digital divide, thinking about people-centric, bringing equality into the conversation, and this idea that we've been trying to train nurses and doctors for years to fill this gap, and that isn't necessarily working, and not to stop that completely, but what else can we do? So maybe this AI thing might fit in there somehow. And then Anne's talk, which I was so very excited about, talked a lot about this idea of replication of one model just doesn't work when you just take it and put it in different places. So how do we do that well? We have a shortage of skilled workers. So let's maybe think about telemedicine. These numbers I didn't know about, where in Ghana, 7 million people were able to be helped via telemedicine, and 70% of the population problems were solved via the phone, and training shopkeepers, of all people, to take your vitals, so you can take the place of actual trained doctors. Again, not saying we should replace doctors, but think of different ways to do that, and putting us in this mindset of thinking of just really different ways that technology can be used to impact healthcare. And then really ended with this idea that we kept hearing iterated over and over again the rest of the day, that we have to really fully integrate into the healthcare system, and not just sit in our silos in Cambridge or Mountain View and come up with these awesome magical ideas and be like, I'm gonna go save the world, and deploy that in a different part of the world. We really have to go and really understand what doctors and nurses and populations are really feeling and thinking, and the problems they're facing each day, to be able to help them solve their problems. And then with that, we really kicked into a set of really inspiring and thought-provoking lightning talks. Andrew kicked us off, and I was so excited that you did this with just what is AI, of level setting. What is this AI thing? Oh, we're really just talking about machine learning, but really, if you're going to get technical, we really are just talking about deep learning, and really diving into, well, why are we looking at medical imaging? Maybe because deep learning responds well to pictures and images versus other kinds of data, and giving us a bit of a history there, which you don't always hear at different kinds of healthcare conferences. So thank you for doing that. And I think what really thought of as you were talking is this idea that it's really important for a lot of us to talk the same language when we are in this space. It's easy to really talk past each other, but when we're saying AI, a physician may be thinking of something totally different. Like they may be thinking of Watson. And someone from Andrew's lab, Andrew's team, may be thinking about deep learning training models, and to really understand how we each think about these words that we say will go a long way in really helping us level set as we build out these technologies. And let's see what else. I pulled these together in the last hour, so bear with me. And next we had Leo jump into a conversation around open data and opening up an idea for having something like the FDA for medical AI, and how health data should be thought of as a public good. That's something that I've heard quite often as well in the field. And the idea that software and algorithms are generally limited by time, so something that you develop now may be irrelevant in a few years. So it's something that you have to really think about often, which if you think about in, for example, a government setting, in the United States, for example, governments will do something like give out a contract for 10 years for an organization to develop technology. So the Department of Defense had a 10-year contract for a new electronic health record system for the DoD. That's crazy, right? After 10 years, so basically, they have today they have a contract. In 10 years, they get to deliver the new electronic health record system. That just, I mean, I know you all understand this. It just doesn't quite make sense. So we have these systems that are counterproductive to the technologies we're trying to build. So Leo, thank you for bringing up the topic that algorithms really are time sensitive, and we have to factor that in as well. And then something else that Leo brought up that I really appreciate too is this idea of interrogating algorithms. I think within the public policy space, we'll often hear things like open the data or release your algorithm. And oftentimes that's met with eye rolling by a lot of software engineers. They're like, okay, you want me to here's all my code, what are you gonna do with it? And so think of ways we can communicate across those lines too. But when you're saying open all the data or make your algorithm transparent, what is it you're really asking for? And asking in that a way where the engineering technologist can give you that same information and not just asking them to release all their code, because that's probably not going to be useful either. And thinking about that as well. And so then John jumped into the naked 24-year-old with meningitis and the abdominal tuberculosis, and talking about differentials. What really struck me there, again, going back to speaking the same language, if you walk into a room, many of you, the physicians in the room, and start talking about differentials, and many of us engineers, I don't understand what that means, and translating that into what does that look like in a database system? Are you talking about red teaming your code, or are you talking about thinking of ways to edge cases, et cetera, and thinking of ways to kind of bridge the gap between what doctors are saying and what technologies are building? Sometimes that alone is really missing in some of these systems that we're deploying. And then he also had a line that was really funny to me, which was, from his understanding, machine learning is now easy and data is hard because we still have men having babies in many of our systems, which is true. You can query cases and result in men having babies because that's how we build our systems. And then we had a session on responsible and fair algorithms and ways to not exacerbate inequities. And then Adam brought us into this idea of bridging medical centers and all the brain power there of research and clinical data, and bringing that back over to how do we bridge that with the startup and industry world, and getting a lot of value there as well. And then we jumped over to John, who talked to us about precision public health, and this idea of participatory surveillance, which I am dying to talk to you more about, and even bring up the idea of Alexa and these other connected devices are tracking you. Are there ways to passively use that technology, which I'm sure many of you have lots of opinions about as well, especially since we had conversations about privacy and security. And then Peter brought in, which I really appreciated, the history of electronic health records, and kind of giving us that visual, if you recall, of in '95, there were just a few places that adopted EHR. There's a lot of conversations around, I don't need to do this, my practice is fine, this is useless to me. And then some 20 years later, the majority of hospitals have EHR. So what is it that really drove them to do that? Always a good insight into history. I'm sorry? Bribes, yes. No, incentives are a huge thing, right? Not that bribes should be a thing everywhere, but what are the incentives? That also is another conversation, bribery in building technology. And then we turned it over to the ethics of building by Professor Cohen, just really the nitty-gritty of what it is to get data, to build a model, and to test a model. Ryan from the Berkman Klein Center, where I'm also a fellow, talked a bit about international AI strategies, from national strategies, because I know he advises a lot of different countries on their AI principles, as well as company principles like Google's and IBM's AI principles. As well. The power that I see there is when companies like Google and IBM release principles, oftentimes a lot of startups and other smaller tech companies watch. So they have a bit of power there as well if you're just thinking from the pure engineering perspective. And then we had that wonderful picture of the hotel in France by Rifat, just kind of, I think for me, reminding me that healthcare is a very old industry. There's a lot of history behind it. There's a lot we can learn from ways healthcare itself has changed as well, as we're thinking of bringing this, quote, new thing into it. Depending on how old or new you view history is, AI has been around for a while. Here at Harvard alone, Barbara Gross brought AI to Harvard in like the 70s. It's not like we discovered AI 5 years ago. Now we're like, oh, I don't know what to do. It's been around for a while. It's a bit we can learn from how AI has evolved and how we have been implementing AI or machine learning or deep learning at some level throughout the past several decades. Ava talked to us a bit about, gave us this image of doctors with a crayon doing contouring, and how there's a lot to improve upon and learn from there as well. And a nugget that I took away from that was that there's no real truth in medicine. There are lots of opinions, and we have to come up with a standard. And on the flip side, engineers like things to be cut and dry and 1 and 0 and having a clean answer to everything. So how do we build this model where it's a bit qualitative, there's a bit of opinion, but we need to have these outputs, right? Like if you bring a 55-year-old woman with leukemia, acute lymphoblastic leukemia, into the doctor's office, like what's your plan of action? There needs to be like a real, like one answer. But it's messy. And then Mark talked to us a bit about geographic diversity, and how a model that is built in one place doesn't work in another place. And then Fung talked to us a bit about the digital data collection, and structured and unstructured data, and thinking about how we collect data. And finally, Rich closes out by thinking about kind of internet access and just access around the world, giving us that one example of telemedicine back in 2003, and working through cases from years ago, like 15 years ago, and seeing what worked and what didn't work in his case. And so in the 2 minutes that I have left, I wanted to pull out a few themes and then turn it over, because this afternoon we're going to break out, I think, into 3 sections for data, implementation and scale, and business model. And I think we're tasked with thinking about how to actually think of solutions and solve all of our problems together. And some of the themes that I think have really emerged from that for me is focus on the problem, not the product or the solution. So less so on the, let's build this artificial intelligence thing because we can. Let's build these models because it's cool. This is how we're trained in engineering school. We go and build things. But why are we building this? Are we building this because we want to solve for tuberculosis? Are we building this because there is an unusually high rate of cataracts in certain parts of the world and we don't know why, and we want to solve for that? Like really deeply think about, and I don't think that's a problem with most of the people in this room. It's definitely more a problem with the computer scientist in the room who focus more on the product than the actual solution. And Lily pointed this out, humans are hard. Collaboration is hard. There's a big theme of working across discipline and really listening to each other and collaborating across the board. A room like this is really wonderful for that. The third one I mentioned a few times is the idea of speaking the same language. Even a few times in these different presentations, we use similar words, but we mean slightly different things. And when that comes down to what we're actually building, it becomes a problem. So really think about how we speak the same language, or even understand that a lot of tech folks, I mean, I'm speaking generally now, but tend to be optimists. And I thought it was funny that was the breakout of the earlier panel as well. There's a lot of optimism in tech. There's a whole book called The Mythical Man Month that all engineers have to read, and it talks about how optimistic engineers are and how systems fail because we're so optimistic. We just hope that everything works. And so there's a lot of optimism there, and whether it's malice or not, it's just, I'm building this AI system, it's going to change the world, I know it will. It's so helpful to have the reality of the people who deeply understand the community, who deeply understand medicine and healthcare, to really do a reality check on that, or really just help us understand how to build systems in such a way that it's not this idealistic view where we're just going to save the world with some technical advancement. And then two more things, incentives. That came out. There was one talk about incentives where there was one person that asked, if I'm working for the Indian ministry and I have to decide between public good or AI, like what do I choose? And those are real questions that affect what gets built in all of our countries. And incentives are something, someone jokingly mentioned bribery, but incentives are something that affect what gets built for years and decades to come. What are the kinds of incentives that we can really think about for people from all sides, the doctors, the technologists, et cetera? And then finally, the theme that I think for me personally is the most important is this idea of deep engagement, deeply embedding in a community, going to understand what demographics in an area looks like, understanding why you may have a differential in a certain area and not in a different area before we build something and deploy it across the board, which is generally in tech what we try and do. We have a whole term for scaling. We just want to scale everything we build. We build something and then we just plop that everywhere and it's going to work. And that's not the case. And so I hope that gives us some food for thought for our transition into the case study and then to the afternoon breakout sessions as well.